All right, here is another question from your homework. It's question number 9. And we're just going to go through this as a class just because I want you to see more. If you're in class, we'd be doing a million of these together. So we're just going to try and do that, go through as many as we need to. So I'm going to go ahead and write down my givens right here. G is parallel to H, that's given. Okay, now this kind of opens up, just please remember, if you know lines are parallel, you know all kinds of lovely things about angles. So I'm going to go ahead and mark that these two lines are parallel. Please make sure that you note which lines are parallel. It's G and H. Okay, do not tell me that P and R are parallel. That's actually what we're trying to prove right here. You see, we're trying to prove that P and R are parallel. So right now we know that G and H are parallel. Okay, we also know, let's also go ahead and mark down that angle 1 and angle 2 are congruent. Oh, and I'll write that down. Angle 1 is congruent to angle 2. That was a given. All right, so to be able to prove that P is parallel to R, when we look at P and R, remember we have all those lovely theorems about P and R, but our angles have to be either alternate interior, alternate exterior, corresponding, or the interior, consecutive interior angles. So in order for that to happen, they've got to be on the same transversal. So when you look at this picture right here, notice this is our transversal. That's the only line that has two angles on it. Okay, the other line only had one angle. We're going to ignore that one. We're going to look at this angle, and then look at these two angles, the only two angles that they numbered right there, 2 and 3. What type of angles are 2 and 3? They are alternate exterior angles. So if we were able to prove that they are congruent, then we can go ahead and say, therefore, those lines are parallel. So that's what we're really going to try and do first. I kind of maybe even make a note of it. We want to prove that angle 2 is congruent to angle 3. Okay, so now let's go back to what they gave us. They told us that these two lines are parallel. I'm going to erase all my markings so that you can see right here. They've told us that these two lines are parallel. So again, when you're looking at transversals, here's the only transversal that cuts two of them, that touches two of those angles. So that's the transversal we're going to look at first. That lets us know that 1 and 3, which are what kind of angles? Angle 1 and angle 3 are going to be congruent because they are corresponding angles. Okay, so we know that if the lines are parallel, then corresponding angles are congruent. So we're going to say corresponding angles theorem tells us that those two are congruent. Now remember up here, we kind of had walked through this, and we're trying to prove 2 and 3 are congruent. That way we can say that P and R are parallel. Notice right here what we have. We've got angle 1 in both of these equations. We know that 2 and 3 are both congruent to angle 1. Therefore, transitive property says that 2 is congruent to angle 3. And the transitive property allows us to do that. And then our last statement, we're able to go ahead and just jump right to P is parallel to R. And that reason is being that alternate exterior angle converse. Okay, so again, remember, sorry guys, we're going to spell this right. Converse. So remember, when you're trying to prove lines parallel, you're always going to use a converse. When they tell you lines are parallel, then you could just use the regular theorem right here, and you don't even have to write it down. But make sure if you're trying to prove something is parallel, put a converse on the end of it right there. And that's finished.